Hello everyone, welcome back to my YouTube channel. I am your science teacher, Sir Roy Kapul, and for this week, we're going to talk about projectile motion. Let's start first with our most essential learning competency, which is to describe the horizontal and vertical motions of a projectile. First, let's start with unlocking of difficulties. So I have here a set of statements and you have to identify what those particular statements is all about. Let's start with this one. It is a body traveling in a projectile motion. The answer is projectile. Let's move on to the next question. It is the horizontal distance traveled by a projectile. The answer is range. How about the third question? It is a combination of uniform horizontal motion and free fall. This is projectile motion. The fourth one, it is the vertical distance traveled by a projectile. This is height. And how about this one? It is a curved path traveled by a projectile. The answer is trajectory. So these are the terms that we're going to encounter with our lesson for today. Let's start first with differentiating the two concepts, force and motion. When we talk about force, we are referring to a push or a pull. Whereas when we talk about motion, it is a change in position with respect to a reference point. And what is that reference point? It is a place or object used for comparison to determine if something is in motion. This reference point is something or an object that is at rest, okay, which will serve as a reference if a particular object is moving or not. Now, to give you an idea, or let's have a short recap of the different types of forces, we can classify it into two classifications, and those are the contact forces and of course the non-contact forces. When speak of the contact forces, it refers to the interaction between the objects that touch. Okay, so it includes applied force, spring force, drag force, frictional force, and of course we have the normal force. On the other hand, the non-contact forces are those that attract or repel, even from a distance. Okay, so it includes the magnetic force, the electric force, and we have the gravitational force. Now, what is emotion? When a body does not change in position with time, we can say that the object is at rest. While if a body changes its position with time, it is said to be in motion. Mean to say the object is already moving. Now, how about the concept of uniformly accelerated motion? A body is said to have a uniform accelerated or acceleration if it maintains a constant change in its velocity. Remember the definition of acceleration, that is a change in velocity per unit time in each time interval along a straight line. This can be along the horizontal, which pertains to rectilinear motion, or along the vertical, which is known to be the free fall. Now, we have two types of motion. If we're going to analyze this illustration, the ant says, my motion is a linear motion. Okay? On the other hand, a bug says that my motion is a non-linear motion. So what is the difference between the two? First, linear motion is a motion in a straight line. On the other hand, nonlinear motion is a motion that is not in a straight line. Next, what are the examples of rectilinear motion, or the motion that travels in a straight line? First, people riding an elevator within a building are in a rectilinear motion. If we're going to analyze the movement of the elevator, it's either moving up or down. Next one, the hot water that falls into the coffee cup from a coffee vending machine is a rectilinear motion. Another example, bowling balls within a lane is in a rectilinear motion. Also, planes in the skies that move in a straight line is in a rectilinear motion. Another one is a ball rolling down an inclined plane is considered to be in a rectilinear motion. And of course, skateboarders going down an inclined path are in a rectilinear motion. In this particular slide, you may see the different equations that you may use in order to solve word problems that involves uniformly accelerated motion. As you can see, the equations are represented by the different symbols that pertain to the different variables in physics, like we have the final velocity, the initial velocity, the constant acceleration, the time, distance or displacement. Of course, we have the average speed or velocity. Another type of motion according to direction includes one-dimensional motion, or it is the motion of a particle moving along a straight line. And of course, we also have here the two-dimensional motion. A particle moving along a curved path in a plane has two-dimensional motion, could either be horizontal and vertical. Now, if we're going to talk about the projectile motion, it is a combination of uniform motion along the horizontal and the motion of a freely falling body along the vertical. And here, the moving body is called a projectile. Remember this particular term. The curved path it travels is known as the trajectory. The horizontal distance it covers is called the range. Then I have here the illustration of a projectile motion in a vector perspective. So as you can see here, we have here the y-axis, which represents the vertical motion, and we also have here the x-axis, which represents the horizontal motion. Okay? The g here represents the acceleration due to gravity. So as you can see, this particular object follows a curved path, which is known as the trajectory. Okay? And there is a vertical and horizontal motion, making it as a projectile object or a projectile motion. In a projectile motion, there are two simultaneous independent rectilinear motion. The first one is along the x-axis. There is a uniform velocity responsible for the horizontal forward motion of the particle. And then, along the y-axis, uniform acceleration is responsible for the vertical or the downward motion of the particle. So here is the projectile launch in a horizontal direction. And we also have here another illustration which shows the projectile launch at an angle. So what are the different examples of projectile motion in our everyday life situation? For example, you are playing a basketball, that shows a projectile motion. In archery, okay? So the art of pointing and shooting the target also follows the projectile motion. And another one is playing soccer. Of course, it also follows the projectile motion as you hit the ball towards the goal. Then I have here the different kinematics equation that we can use in order to solve projectile related word problems. So if the horizontal motion is involved, there you have the set of equations. And of course, we have the different or a different set of equations for the vertical motion. Just look at the different variables or the symbols that are being used to represent the different variables in physics. Now I have here a sample problem. If a bullet is fired with a speed of 600 meters per second horizontally from a height of 48 meters, how long will it take to hit the ground? What is the range of the projectile? Assume that there is no air resistance. So the first thing that you have to do in a problem solving is to identify first the given. So the given from the problem, we have here 600 meter per second. So that pertains to our velocity in the horizontal direction or the horizontal motion. And then you also have here the height. So the height represents the vertical distance of the place. So we have here 48 meters. So based on the problem, we are looking for the time. And of course, we are looking for the range or the horizontal distance. Now, given Vix or our velocity, which is 600 meter per second, and our vertical distance of 48 meters, so we're going to use first the formula dy is equal to Viy multiplied by the time plus 1/2 times the acceleration due to gravity and the squared of time. So we can simplify. So since we are looking for time, uh, using formula transformation, we can simplify it into t is equal to the square root of negative 2 dy over g. Then substitute the given. So you have here the dy of 48 meters. So multiply it by 2 and then divide it by the value of g. So our g is not given in the problem, but it's already understood that g is always equal to 9.8 meter per second squared. So if you have here 2 times 48 divided by 9.8, then the square of the answer would be t is equal to 3.1 seconds. Okay? And then if we're going to look at the range, which is dx is equals to Vix multiplied by the time, just substitute again the given. So there in the problem, you can see 600 meter per second, then multiply it by the computed value for time. And the answer would be 1,860 meters. So that is how we use the different equations involved in the kinematics equation. Now I have here analysis. A school introduced the sports of archery so that they can send players to division and regional sports competition in the future. A student tries out. He was taught how to handle the equipment. Then he sets a bow and arrow and direct it to the target. So the arrow is almost in direct line with the bullseye target 30 meters away. Will the boy hit the bullseye? Why? So given this particular problem, what do you think will be the answer? Very good. The answer is no. Okay? So if the boy directs his arrow in direct line with the bullseye, remember that there is the concept of pull of gravity or acceleration due to gravity. So by directing the arrow in direct line with the bullseye, of course, there's a tendency for the arrow to move in a lower position than the target because of the influence of the pull of gravity. So therefore, the boy should aim for a higher angle, okay, in order for him to hit the bullseye. So that is the answer for this particular question. Here are the different references that I made use for this presentation. Thank you so much for watching. For questions, just write it on the comment box. Thank you.